Okay, so let me share my screen. And then let's go and look for a titration of a weak base, right? So here's an example of a titration of a weak base, right? Can you guys see my screen okay?
Yeah.
Yes.
Okay. So the midpoint here, at the midpoint here, the POH will equal the PKB. Now POH is 14 minus the pH, right? So what we're looking for is not the pH, but the POH to be equal to the PKB right here. You can see my screen, correct?
Yeah.
Okay. So for this one here, our PKBs here, 3.36, 4.74, 7.96, so forth. And then they provide us the pH of a solution. So for example, if I get a Erlenmeyer flask out and I put in, this is the unknown base, right? So if I put in, what are my solutions here? Just put in here maybe 10 mils of my weak base. All right. And then in my burette, how much do I have in my burette? 50 mils. Do I have anything in here?
I don't think so.
Okay.
Okay.
So now I have in my burette my 0.1 molar HCl. And I have here 10 milliliters of my weak base. Okay. I can click on the weak base and it says that the pH is 11.84. All right. Now, what is the POH of this solution? Do you guys know what the relationship between pH and POH is?
I don't, but Alyssa probably does.
Alyssa, did you gather that, the difference between pH and POH?
Isn't the POH the 14 minus the PKB?
That's right. So pH, let me get a little pen here. pH equals, that's not right. POH, let's try again here. pH plus POH equals our, let's see, a little bit bigger there. Let's see if this turns out a little better. pH plus POH equals 14. Okay, so if we look at our POH, then what is our POH? If our pH is 11.84, what's our POH?
So we just do 14 minus 11. 2.16.
Okay, 2.16. So our first PKB will be 3.36. Is that right? 3.36. If we are at 3.36, so we can do 14 minus the 3.36, which is our pH minus our PKB, right? That'll mean 10.64. So methylamine, when we reach a pH of 10.64, it'll be equivalent to the PKB of 3.36, or the pOH of 3.36. Now, Alyssa, do you remember what it means when we reach the pKb or the pKa of our weaker acid or base? Do you remember what that means?
That means we're at the halfway point.
That's right. Very good. That means we're at the halfway point. So we want to get to the halfway point for this titration curve, right? So I don't know why this is blacked out. Let's see if I click on it, if that helps anything. There we go. So our pH is going to start basic. It's going to have a little bit of a shift there, and then we're going to get to the halfway point, and then it's going to come to a point where it completely drops. And at the halfway point, the pOH at that halfway point is equal to the pKb. Okay? So we want to reach a pOH that is the pKb. And if the pOH, the pKb is 3.36, our pOH should be 3.36, and we decided that that would mean a pH of 10.64. So we want to perform a titration and reach 10.64 and then calculate the volume added. Right, Alyssa? Does that sound familiar?
Yes. Yes.
And then after we calculate, then we'll calculate the volume when we reach the pOH of 4.74. We'll calculate the volume at pOH 7.96, and so forth as we go. Now we'll recognize the endpoint, because as soon as we get to the endpoint, the solution will become very acidic, almost to the same acidity as our acid that we're going to be adding. So the acid here is pH 1, right? If I click on this, it says that the acid is pH 1. What's that?
What did you put in the flask that you got? You put
This
like
one
10
here?
milliliters. Yes.
I put 10 milliliters of my unknown weak base.
Oh, that's it.
Yeah.
Oh, okay. Okay. That's fine. Thank you.
Now, let's see. Alyssa? No, Camille. Camille?
Yes.
If I click, you can see what I'm doing here, right? On my laptop, on my desktop still, right?
Yes.
If I make you the presenter, then a button like this one down at the right here, see how there's a little button down at the right that says share your screen? You'll be able to share your screen. So if I make you the presenter, you'll be able to share your screen. And then what you'll be able to do is open up, go to the instructions for the lab, and open up your own unknown base problem, right?
Okay.
And then we'll be able to follow along as you perform the titration. And then if we get the right answer, we'll have to cross our fingers, we might not, but if we get the right answer, right, you can actually use that value for your lab write-up. Does that make sense? Camille? All right, so I'm going to make you the presenter now, and then you can do that, okay?
Okay. Okay. So can you see my screen?
Yeah, great.
Okay. So start with first the Erlenmeyer flask, right?
Mm-hmm.
And then get the weak base and hydrochloric acid.
Yeah, that's a strong base. Now we
Um,
don't want to, well, sorry, that's not strong base, it's strong acids. So you could close the strong bases.
yeah.
So you don't want,
1 molar.
you don't want 1 molar. I think you want to start with like 0.1 molar. So it's near the very bottom there.
Oh.
Any of these acids, they're all strong acids, so any of them would work, but HCl, there we go, that's 0.1 molar. I really don't know. We don't know the concentration of the acid. Did you say you did this one once, Camille?
No, I haven't done this one.
Okay. Just to try to figure out what a rough concentration might be. So, yeah, into the unknown. Maybe if we just start with 10, okay, that's fine.
Okay, and then so the pH of that is 12.28.
Okay, very good.
So then you subtract that from 14.
Yep, that would be if we wanted to find the pOH. And that would be only, I mean, we can use those PKBs up above to find out at what pH we want to stop by identifying what the pOH would be that we want to stop at.
Okay. So I don't need to find the pOH right now?
Not of our solution. Okay, so Camille, it's officially 12:01 now. Or sorry, Alyssa. No, it's Camille. Yeah, Camille. It's officially 12:01 now, and we're getting a little bit of a larger crowd. So why don't you catch everybody up in terms of what we're doing? Is that okay?
Yeah, I'll try my hardest. Okay, so I have my screen on there for my unknown base problem right now in the lab. And so far, we've just kind of gone over how to calculate, like, what do the pH plus pOH equals 14, right? Yeah.
Mm-hmm.
And then I don't know how you got to that graph.
So go ahead and open a Google page and type titration of a weak base. Very good.
And then, I think you use this one.
And yeah, click on that one there. It'll get you to it. Just click right there.
This one?
Yeah.
Okay. So then we talked about how we have to reach this midpoint right here with the PKB and the pOH, because as it goes over, it drops. That's right. Yeah.
Yeah. So at that midpoint, when the pOH of the solution equals the PKB of your unknown base, at that midpoint, you'll know you're halfway through the titration. All right?
Yes.
So we are going to know, we're going to record the volumes of the acid we've added when we pass the different PKBs of the possible bases, right? So yeah, click on there, and we'll look on. These are the possible bases. Yeah. So we'll record the volumes when we pass those pOHs. Okay. Now,
I have a question.
Yeah.
So is this just like the pKa's for finding the acid?
It is. So did you do that one already, Chance? Find the weak acid?
I'm in the process of doing it right now. So I just learned how to do pKa and doing the graph similar to the one that was just shown, but slightly different, going up instead of down.
Right.
So I haven't finished it, but I'm in the process of it right now.
So good. Now we need to, the only difference there, Chance, is that for this one, we need to recognize that there's a relationship between the pKa and the pKb, and that in the weak acid one, we titrate to the pKa's and record those volumes when we get to those pKa's. And then we would find out where our endpoint is and find out which of the pKa's corresponded to that endpoint. And then that'll give us tell us which acid it was, and then the endpoint, or actually the midpoint, is all we really need. It will also tell us the concentration of the acid. If you remember to multiply it by 2. Alyssa and I went through the whole deal, and we forgot to multiply it by 2. And you can watch that
Yeah,
video.
I think I was just watching that. I think I was watching that video actually earlier.
That was frustrating. But
You guys got the acid right, but the concentration wrong. Yeah.
yeah, because we had only gone halfway. You only have to go to halfway and then just multiply by 2.
Okay.
So now we have to remember that there's this relationship between pKb and pKa. pKa plus pKb will always equal 14. So in this one, we're going to reach certain pKb's, but if you scroll down a little bit, Alyssa, yeah, the pH right there is all that it's giving us. It never gives us the pOH. So we have to kind of do a little bit of minimal calculations. Camille, do you have Excel?
Yeah.
Why don't you open up a little Excel sheet so that we can keep some notes for ourselves? So in this Excel sheet, we're going to write our list of pKb's that we're after. So you want to write down all those different values?
Hold on, I gotta go back.
Actually, I'll tell them to you. I have them right here. Okay, ready?
Hold on. Okay.
3.36, 4.74, 7.96, 8.77, and 9.42. Okay? And to the right of that, why don't you make another column that says pH. All right, and then you can go down to that one there, and you can put an equal sign and say 14 minus, and then click on A2. Push enter. And then you can highlight that and drag it down so that it can do all those cells by itself. There
Like
you
that?
go. Yep. If you like,
You need to grab the box on the bottom right to do that.
try it again.
Okay, hold on. I'm not proficient.
There we go. Whoops. Okay, there.
Wait,
I think you're there. Drag that bottom box, the bottom right box.
Okay, wait. Now drag it down. Ah,
Yes.
No, you don't have to double click it.
You don't have to have that done. Just escape, push escape. And now go click on there and drag that little bottom box. There you go, all the way down to the bottom. Perfect. All right. That's it.
Oh,
So those are the pHs that we want to record the volume. So why don't you write in the next column volume? Volume of acid, maybe. There we go. Now we got a nice little sheet to monitor as we perform our experiment here.
So I had a quick question.
Yeah.
Sorry to interrupt. I just kind of joined at 11, 12.
Yeah.
So I'm kind of don't have any idea what pOH is. And I noticed you used 14. So is that just universal? That's what it seems like? Or is there a way you figure that out?
Well, do you remember what pH means?
Yeah.
What does pH mean?
The acidity
It's the
level.
There's a mathematical value for it. Do you remember
Oh,
that
the
business?
mathematical equation for pH?
Yeah.
Um,
The P function is just a mathematical statement, right? So yes, pH
Okay.
is a measurement of acidity, but
is that the negative log one that you're talking about?
that's right. So Px is negative log of whatever x is. So
Okay.
pH means the negative log of the hydrogen ion. pOH
Okay.
means the negative log of the molar concentration of the hydroxide ion. So
Oh, okay.
because of that, when you have a water molecule and you have some of those water molecules releasing their hydrogen ions, because that's what acid is, hydrogen ions floating around in solution, then that means there's a number of water molecules that have the hydroxide ion. And so they're all, and that's basically has to happen because of the nature of the water molecule losing the hydrogen ions. So there's always this relationship between pH and pOH. If you add them together, it will always equal 14. If you just take the hydrogen ion concentration, not the pH, but just the hydrogen ion molar concentration, and multiply it by the hydroxide ion molar concentration, that will always equal 1 times 10 to the minus 14. So, yeah, that's why pH plus pOH always equals 14.
Okay, thanks.
Yeah. For any of you who are, and hopefully you'll catch up, we started over kind of at noon, and I think everybody's here, but if you do want to go back, we're recording this and we'll post it at the end so you can go back. But if you have any questions right now, feel free to ask them as well. All right, Camille, what do we got to do next?
I'm going to guess something in the lab thing.
We just have to do the titration now, and when we reach 10.64, we want to stop and write down the volume in that spreadsheet, right?
Yes.
Actually,
So
Camille, why don't you go back to those? Well, yeah, that's all right. Somebody's got to remember for us. 10.64. We got to remember, right? Here, let me take.
I put it down in my notebook.
Okay, great. 10.64 is our first one. So here we go.
Okay. So I'm taking the one I poured into my flask right here, right?
Yeah, I don't think we have any acid in our burette yet, though, do we?
I don't think so. No, nothing.
So 52 mils. We'll fill it up to the 0 mark. Perfect.
Okay.
All right, so let's titrate.
Okay, I always struggle. How much should I put in at a time?
Well, we kind of know that we're going to have to do it 2 or 3 times. You know, you just don't know perfectly. But that's what we need to find is the perfect midpoint. So let's just start doing 1 mil at a time and see. We don't even know because we might have the wrong concentration of acid, right?
Okay.
So now the pH is 12.04 at 2 mils?
Yeah.
All right. What was it again? 10.64?
Yes.
Okay, let's go. Make sure you don't go past 10.64. I mean, if we do, that means it's time to stop. I mean, we have to start over or whatever. Okay, let's slow down a little bit.
Okay. Should I lower the amount?
I think maybe 1 more mil is okay, and then let's go down to 0.1 mils. Maybe a couple more mils.
Should I do one more?
Yeah, 1 more. All right,
Okay,
there we go.
now.
So maybe 0.1. Okay, so hold on just a second. So you guys can recognize right now, it's taking about a half a milliliter to go a pH unit. All right. So we want to be at 10.64 halfway through. I mean, we want to be not just right at the beginning of 10.64, but we want to look at, with the transition between 10.65 to 10.64 and then 10.64 to 10.63 to make sure we get right in the middle, right? Because it feels good to get the exact number. All right. So anyways, 10.64. As soon as we get 10.64 volume, let's write it down. Keep going. All right, there it is. So we're at, what are we at, Camille?
43.3.
Okay, very good. 43.3. So let's go jot that down before we forget in Excel.
Oh yeah, sorry.
Okay, how about in column D there? We'll call this volume of acid end midpoint. Okay, and then C, title that one volume of acid beginning midpoint.
All right, but that's okay.
So if you double click on, see that C, if you double click on, move to the right a little bit and up, right to the end of the column of C and double click on it. So scoot over to the right a little bit. Right there, double click there. Yeah, or whatever. Just, yeah.
Make it bigger.
Yeah, very good. Okay. Now we can go back and finish up. I think we're going to be at 43.8 for our, when we get to 10.65, because that's what it looked like it was taking, about a half a mil, but we'll see. So go ahead. All right.
Okay.
So 43.8. Go ahead and type that in.
Okay.
Very good. And then that's 43.3. What's the average between those two?
Okay, I really don't know how to do that in Excel.
Well, if you click on E, click on the next column, right there, yeah, and then just equal sign. Start typing the word average, and then double click. No, go back a little bit. Go back a little bit. All right, no, backspace.
Oh.
AVE is how you spell average. There we go. So click on average. There you go. Double click on that one now, and then highlight the 43.3 and the 43.8. Highlight it, or drag them so you highlight them both.
Oh, I'm sorry. Hold on.
Try again.
Average.
Yep, just click one and drag to the other. There we go. Now push enter.
Okay.
There we go. Got it. All right. So the next pH that we need to stop at is 9.26. 9.26.
Okay. So keep going on this particular one right here.
I had a question. Sorry.
Yeah, go ahead, Chance.
How did you get the end, like the 43.8?
Did you see how we did that?
I saw you doing it, but I don't know what triggered you to write that down. Like what do you look for?
When we got to
Right.
when the pH shifted to 10.63.
Oh, okay, got it. All right,
Okay.
thanks.
All
Should I leave
right.
it on,
What?
or should I put it back at 1 because we have to go all the way to 9.26?
Why don't you bring it down to 44, and then we'll add 44 more mils of our acid.
Okay, so just pour the rest until 44.
Yeah, just do 2 more of those little clicks. All right.
Okay.
Now we're at 44. Now you can add up to 44 mils from your acid into the burette. All right. Okay. Now we also have a way to remember the volume, because it says that the 250 milliliter flask that we're titrating into has 54 milliliters. We see that?
Oh,
see-
yes. I see.
So that
Right here.
54 mils is 10 mils of our unknown, and then the rest is our acid that we've added.
Okay.
Does that make sense?
Yes.
So as we add acid now, it's going to be kind of confusing. It's going to say 1, 2, 3, all those values, but that's not how much we've added. But down below, we'll always know it's whatever that volume is minus 10.
Okay.
Okay, so
So-
let's go. Wait, what value are we looking for now this time?
9.26.
Really?
I'm pretty sure. Yeah. let me-
Excellent. Wonderful. Okay, great.
So should I start with 1?
Yeah, I think so. Because I think it's going to be kind of far
Okay.
Oh, wait. Slow down a little bit.
Oh, sorry, I went over it.
Okay. So it's actually okay that you went over it, because I think that what we're seeing here is the pH is changing so fast that we're likely...
Yeah, it went from like 30 to 2.3.
Yeah, it's likely that we're coming to the end point of the titration. All right? So if we're coming towards the end point of the titration, we're not approaching halfway the titration. So it probably means, go up to the top there, just look at our acids.
This one?
No, just look at our list of weak bases. Look at our pKa's up at the top, pKb's up at the top.
Okay.
It's likely that ammonia, it's not likely that it's anything other than methylamine, because the ammonia, we haven't got enough. The POH is not stable. So when you reach these pKb's or these POHs or the respective pHs, the pH shouldn't be changing much, right? If that's the acid that you have, because if that's the acid that's there, that region, that value, that pKb, that region around the pH will be very stable. Okay. And we're seeing it becoming very unstable now because we're running out of the base. It's disappearing. So it looks like our unknown base is the methylamine. Does that make sense, Camille?
Yes, yes, that does make sense.
Now, why don't you go back to your Excel sheet and let's calculate where our predicted endpoint would be by making a little thing in column G. Let's title this column predicted endpoint. And it's just an equation of equal sign there, and then E2 times 2.
Is times in this just an X?
Shift 8. That's the time sign, times 2. Equals. So we're looking to be at 87.1, our volume of 87.1. Okay? So let's go back to our titration now and recognize that, where are we at right now? 84. We're at 84, right? Is that true, Camille?
Oh, yes, because 40 plus 44. Yes, 84.
And because down below, again, in the 250 milliliter flask, it says 94, right?
Yes.
All right, and what did we say? 80, what was the volume we're looking for now?
87.1.
Okay. All right. So let's just double check that our endpoint is actually coming. Now, somebody else want to tell me, Aisha, do you know how we know our endpoint is getting close?
Sorry, I was looking at something else.
That's fine.
I didn't catch it.
Do you know, Aisha, how we know that our endpoint is getting close? Not really?
I don't think I know.
Okay. Camille? No, sorry, Alyssa. Alyssa, do you know how we know our endpoint is getting close? Or actually,
The
Alyssa?
drop in pH.
Yeah.
Okay.
Yeah, that's right. I thought you would know, so very good. It's because our pH is changing so quickly now. For every little amount of acid we add, the pH is changing quickly. If there's base that's consuming the pH, then the pH won't change. But that's an indication that we're not changing. Our pH is not changing. All right, Camille, bring us home. How much do we got to add? Nice and carefully. Maybe we go to 85. Well, I don't know. Maybe 86. 6. So maybe 2 more mils, but then nice.
Put this down.
I think that if we do 2 more mils, we should be okay. Actually, do 1 at least. Let's find out where we're at. Click on the flask down below so it brings up the. There we go.
Okay.
So now we're at 85. Oh, we
What
already.
just happened?
What?
Wait, I'm confused at what just happened.
Well, sorry. That's the pH of the burette. See?
Oh.
It says to the left there. So go ahead. Yeah, we're at 9.07. All right, good. So go ahead and drag it in there. Okay. And then we're at 95. Go ahead and go to 96 maybe.
Just do 1.
1 milliliter. Let's see where we're at. Pour it. Let's make sure. Okay, so it says 8.81. Very good. Excellent. So 97. 1 more mil probably. Wait, what did we say we're going to? 97.1?
No, I think it's 87.
Sorry,
Hold on.
87.1?
Yes.
Okay. So maybe we do 0.1 milliliters at this point then. We're at 86 right now. Let's go ahead and do 0.1 milliliters.
Keep going.
What's that?
Do I keep going?
Yeah, we're okay. We're at 8.7, 8.73, 8.69. See, the pH is changing pretty fast now with even just really small volumes. And we're predicting that at 87.2, which is 97.2 down there on the bottom, the pH will get very close to, 2 or 3.
Okay, so I need to go to 97.2.
97.2, yeah.
Okay.
Okay, keep going.
Oh, that just jumped a lot of pH.
Yeah. Yep. Okay. Very good. So, pretty close, our calculation, right?
Yeah.
So essentially, I think that we're ready to do a titration. Or sorry, do a calculation.
Okay, I was going to say that we just did that.
So let's go back to our Excel sheet. And we'll use that midpoint, 43.55.
This one.
Yeah. Multiply it by 2. Actually, so we're going to use the 87.1 probably. Hopefully it's not, because our final point was it looked like it was about 87.3, right? Or no, where did we end up at right now? Where are we at? Oh, did you lose me? Am I still there? Can anybody hear me? Am I lost? Where are you guys going? Why don't you return the DVD so we don't get them when we're fine? Oh, that's wonderful. Yeah, I got my internet cut off, so I gotta try to connect back on. You look beautiful. Your hat looks wonderful. Okay, see ya. Thank you for doing that. Thank you for saving our lives. Yep.
not sure what I was supposed to multiply.
Alyssa, what do you think we need to do?
What part are we on?
Well, we tell her, Camille, what are we at?
Well, we just finished the titration, and then we went to use the endpoint to do something that I wasn't sure what was happening next.
So we can multiply the volume needed to titrate by the molarity of the acid we used to do it, and then multiply it, or we'll technically multiply 1 over the amount of liquid that we were using for the base that we used to titrate, and then we'll get the answer, and then we'll have to multiply it by 2 because that's the halfway point.
So, Camille, or sorry, yeah, let me see if I think I can. Yeah, I'm going to take the presenter for a second here, and
Okay.
we'll do a calculation. All right. So, what goes to the right of our equals sign?
Is it the molarity of the unknown weak base?
That's right. So moles of base over what?
The amount of liquid, so liters.
Yeah, the liters of the solution of base, the basic solution. All right, what can we start with top left here?
Do we start with how much we end, like the end volume?
Yeah.
That was 43.55.
Now, we don't want to make the same mistake we made last time, which is forgetting to divide by or multiply by 2. So what's that multiplied by 2?
Let me use my calculator really fast. 87.1. Oh, that was already done.
Okay, 87.1. All right, so it's 0.0871 liters of our acid. Okay, and then we go liters of the acid to what? Where are we going to be able to go from there?
Moles.
That's right, moles of our acid. Do you know how we're going to get there?
Do we look at how much we
0.1.
use? What is it? 0.01.
0, is it 0.1 or 0.01?
Oh,
What do
0.
you guys-
Yeah, that's the molarity of our acid. Okay, very good. Now we can go from moles of acid to moles of base, right? And you could look up this acid if you wanted to make sure it was a 1-to-1 ratio, but the titration curve also showed us that it was a 1-to-1 ratio, right? Because there was only one region of kind of the plateau region or the buffer region. Okay, what goes down here?
I don't know. I don't know.
You don't know?
Should know.
We're
Oh,
supposed.
liters.
Yeah, liters of what?
The weak base, the unknown weak base.
That's right. Very good. So, how many liters did we use? Do you know?
Well, when I look at the flask, it says 97.8, but you subtract 10, so it's 87.8.
That was the liters of the acid, right? That we added?
Yes.
But what goes down here?
Liters of solution.
It's the liters of the base
Put 10
solution.
milliliters in there.
The 10 milliliters, right. Remember we added 10 milliliters? Camille?
Oh, yes. Okay.
All right. So, what does that tell us? Anybody got a calculator?
I have one. I'm doing it really fast. Um, 0.871.
My goodness. Here comes the hard part or the scary part. All right, let's go. Why don't you, I'll give you the presenter. Show us your screen. And 0.871 is our predicted concentration. Anybody see any mistakes that we're making?
I don't. So do I put that's like the answer?
So the unknown weak base was, we said, the methylamine, right?
Yes. And then this is
0.871, hopefully.
Did you multiply by 2?
We did multiply by 2. Now the endpoint was a little bit further than the 0.871, so if this is wrong, then we'll use a little bit higher concentration, but let's check. Hooray!
Yes.
Praise the day. Okay, so it did say it was 0.873, which is a little bit higher, and the endpoint showed it was a little bit higher, but that's all right, we got it. Okay. Anybody else want to request one?
The acid base one?
The acid base one?
The third one on the list.
Oh, let's see.
Can I stop sharing my screen?
What's that?
Can I stop sharing my screen now?
Yeah. Oh, the 2-acid titration, is that what you're talking about?
Yes, that one.
That one's lame. Let's wait for that one. Let's get all the other ones first. Is that okay?
I had a question about this one.
Yeah.
So I was working on it earlier, and I was following the steps that you guys were just doing. But when I started to do the titration, starting pH was like already low, like lower than or higher than everything. I don't know. I think I'm just confused on.
So the one we just did, right, was the unknown base, right?
Yes.
Okay.
Yeah, that's what I was working on. So when I just started the titration, the pH, when I added 1 milliliter, it was at 6.35 already.
Okay. So, Camille, what were those values that you had
Excel.
in your Excel sheet, just for fun?
Which ones?
The
PKB and pH.
the PKBs. What were the PKBs?
3.36,
Yeah.
4.74.
7, 5, 6, 8, 7, 7, 9, 4, 2. Yeah,
Mhm.
sir, I have all those.
Okay.
Uh,
Yep. Next.
okay. 7.96,
Uh-huh.
8.77,
Uh-huh.
and 9.42.
Okay. So, you guys can see my screen, right? Is that what you're watching?
Yeah.
Okay. Okay. So then the pH. This is the PKB. And what am I trying to figure out here? I'm trying to figure out the pH that we would be looking for. Yeah, so it's 14 minus this. So theoretically, the pH could start as low as 4.58, but it shouldn't start any lower than 4.58.
I have a question.
Does that make sense, Chance?
Yes. So wherever it starts, you just keep going, and it just keeps getting lower and lower. So like I couldn't get anything above that.
Above 4.58?
So like the first time I put 1 milliliter in, it went from 7 to 6.454 or whatever, and then it kept going lower and lower.
Okay. So it might be that your concentration of acid is too high. So because we don't know to start off with what concentration of acid to use. We use the 0.1 molar. That's kind of a safe range to start off with, but they offer us in this experiment.
Yeah.
Yeah, they have
I
a
started
lot
with
of
that as well. So that just means mine's different.
So maybe try to go to the
5.2.
0.01 molar, yeah, the 10 millimolar.
Okay. So where should it is there a certain place it should start at? Like how I wouldn't know how, like the next one I try is wrong too. I wouldn't know. I don't know.
Then the next one, if just
Like
I
if
would
I did 0.01 and it still is, I don't know. I don't know.
well, if you have to, you can make more dilute. I mean, we have the glassware there to make more dilute solutions. But so here, let me refresh this unknown base one, right? I have. You guys can see it. True or no?
Yeah.
Okay. I mean, I'm not going to be able to refresh it 100 times, but you can just hold this solution right here, 11.2, right? So it tells us the pH of the stuff, right? So,
Okay.
I mean, it should always be, and if you move that one out of the way, now hold this one, it's telling us the name of the flask, and it's 11.2. So, if I refresh it again and do that same thing again, actually, all I really need is this stuff right here. 8.54. All right, so refresh it again. And, it's pretty telling right off the bat, 12.16, what the base can and can't be based on the pH that it is initially, right?
Okay.
But anyways, so all of those should start at the highest, what did we say? Or sorry, the lowest pH it can be is, it's going to be around 5 at the lowest. Sorry, the highest. Yeah, it's going to be about 5 at the highest. No, sorry. The lowest it can be is about 5. The lowest it can be about 5 because the pKa, or your buffer zone is going to be at 4.5 for the lowest pH one, right? So, anyways, yeah. I don't know what kind of a scenario you would have when the base was at a pH lower than 4.5 to start with. That wouldn't make sense. I mean, it's possible that you're in the unknown acid portion. Okay.
Well, I can figure it out.
Any other questions?
I have a question.
Yeah.
So whenever we do the weak acid or weak base titrations, do we use the weak acids and bases to titrate it?
No. Just use a strong acid or strong base.
Okay, thank you.
Yeah, so weak acid, just use a strong base. Weak base, use a strong acid.
So for other ones like this one was the unknown base, and then we have like the unknown acid one. Is it pretty much the same steps?
It's a little bit more straightforward with the unknown acid because you don't have to worry about the pKb because you're not looking for the KOH, you're just looking for the POH, you're looking just right for the pH. So
Okay.
yeah, it's the same thing. And there's those videos that are already on the homepage for the Canvas lab page that you can look at. I think there's a couple videos where we've tried it. Nikki, where are you at? What have you done so far?
I'm just following along in the acid or the base problem.
Okay, so you're trying to get your own one done?
Yeah, I opened up like an Excel and I'm trying to so I watched you guys do it, and then so now I'm just trying to do it on my own.
All right. What other ones have you got done?
The acid base titration, the silver nitrate, and then I'm working on. I was looking at the unknown acid one as well, and then and I figured it's the same, similar to the unknown base, just with an acid.
Uh-huh.
So I was looking at these two.
Okay. Aisha, do you want to have specific help on one of them?
I'm watching the video, so I think the videos really help. So
Okay. All right. Anybody else want to work on something? Or you guys want to go free for a while?
Is there a video on the 2-acid titration one?
I haven't made a video for that yet. Do we want to try to deal with that now?
I don't care. Whatever's fine. If there's gonna be a video, then I'll be okay. But I know I'm confused on all of them. But I know I'm
What's
confused
that?
on that.
I
know I'm confused on all of them, but I'm a little confused on that one as well.
Okay, you say you're confused on all of them, but you're also confused on that one? Is that what you said?
Yeah, well, like the other ones, like since we did this one, it will be a little bit easier to figure out. But the 2-acid titration one is just a little confusing. I might be the only one that thinks that, but
No, I think it is the most difficult one, but I'm hoping that if you guys do all the other ones, then when you reach it, your learning will have prepared you for it, and you'll have an opportunity to conquer the beast yourself. But
well, I can wait until I finish a few more, and then I don't know, on class tomorrow or Friday or next week, I can ask questions on that one too after I see if I can figure it out.
Okay. Just really quickly, it's an unknown acid, a weak acid, and a strong base. A weak acid and a strong base. So here, let's go to 2-acid titration. It says up here that it's a mixture of trichloroacetic acid and alloxonic acid. It says if you look up these compounds in the book, you see that they have a pKa of 6.63 for the alloxonic acid. The pKa for the trichloroacetic acid is too low. You're not going to be able to effectively identify that pKa. When you titrate 2 acids together, the weak acid is the one that gets the protons. Let's see. The weak acid is the one that gets the protons first. So if there's two acids in solution, strong acid and a weak acid, they both are dissociating to some degrees. Strong acid completely dissociates. That's what makes it a strong acid. Whereas the weak acid, if there are protons around, it will be taking them up. So as you remove protons, you're going to be removing protons from the weak acid first. So if we have our acid mixture there, Erlenmeyer flask.
I have a question.
Yeah.
So, like, if that one is this like a pure mixture? Like, there's no water in it?
There's water in it for sure.
There is water in it? Oh, okay. Darn it.
Why? What were you thinking?
I was just thinking that if we could find the concentration of the oxalic acid, then we would know the concentration of the other one.
Oh, I see. Well, here we can look at titration of weak acid and strong acid mixture. Titration of mixture of weak acid and strong acid. Okay. That's a little more complicated than we want to get into. Let's see if we can get a good image here. So there's a couple of examples. This one's probably one of the best. We're going to have, we're going to consume one of the acids first, and then we're going to consume the second acid later. Okay, so the titration is going to have two bumps like this for the mixture of mixture of a weak acid and a strong acid. So let's just give this a shot and see what it looks like. So I have 10 mils of my acid mixture there. I'm going to also get a strong base in my, I think I'll start with the 0.1, well, I think last time I did this, the solution, the concentration was kind of high. So I'm going to start with a 1 molar. So if I add, I'm just going to add 0.1 to start off with so that we can look at the pH. So the pH is 11.63. Now again, when we get to 6.63, that's an indication that we're halfway through our weak acid portion, right? So I'm adding, what did I just add? Did I added, oh, what?
Yep. You did.
I added
0.1.
0.1 milliliter of sodium hydroxide, and I'm already at 11.63. So I'm already way basic. Does that make sense?
Yes.
So I have to try again with a different solution. So my acid mixture, how many milliliters did I add that time of my acid mixture? Did I just add 1?
I'm not sure. You weren't saying anything.
Okay. So I added 10 this time. I added 10 milliliters of my acid mixture. And let's get some solutions. Strong base. Let's do the 0.1 molar this time. Okay. So 1 milliliter. Still very fast. Went to basic really fast. I added 10 mils. Let's see if I add 90 mils now of the acid. So that brings me back to, so now I have 100 milliliters of acid in here, and I added 1 milliliter of my 0.1 molar, and it ended up at pH 2.87. So I'm still acidic. So how about I add 0.1 milliliters there?
Are you trying to get to 6.63?
I need to watch the volume when I'm at 6.63. When I'm at 6.63, I need to know what the volume is, because that'll be an indication that I'm halfway to my weak acid, right? Halfway done titrating my weak acid. So it looks like I should have dealt with, and maybe when I do it again, I'll take my 0.001 molar sodium hydroxide. But right now I'm going to add 0.01 milliliters of this stuff. Whoops, I already passed my pKa?
Yes.
I did. Okay, so, and that was only 2 mils, so that would mean it would take 20 mils of my 0.1 molar. So that's, wait, but I added 100 mils of this stuff. So if I add 100 mils of this stuff, it's going to take 20 mils of my 0.1 molar. All right.
You know that.
What's that?
How do you know that right there? If you have 100, it's 20.
Well, I just added, the one that I just did, right? I had 0.1 molar HCl. Sorry, 0.1 molar sodium hydroxide. 0.1 molar sodium hydroxide, 100 milliliters of my unknown acids, yeah. And 100 milliliters of the unknown acid only required 2 something milliliters of my 0.1 molar stuff. So if I did the same thing, but this time only did not 0.1 molar base, but 0.01 molar base, then it should require twice as much, because it's 1/10, or not twice as much, it should require 10 times as much, because it's only 1/10 the concentration. Did you follow that?
Yes, thank you.
What's that?
I said yes, thank you.
Oh, good. Okay, so where are we at? We're looking for our strong bases again, but this time we're going to do what? Only the 0.01 molar sodium hydroxide, right?
Why are you using sodium hydroxide instead of hydrochloric acid?
Well, because it's already acidic. This is an acidic mixture. For the one that we did, that you led us in, you had an unknown base, right?
Oh, this is an acid. Okay.
This is an acid, yeah. So I want to get a burette, and we're going to put into it our .52 mils of our stuff here. So we said that if I put in 100 mils here, 100 mils there, that it was going to require about 20 mils of this stuff here. So let's see if it's true. I'll just put in 1 milliliter to get the pH. 2.65, still very acidic. Okay, and just keep going here. So what did we say? Oh, it was 20 mils to get to the halfway point, right? So not to the complete titration, but to our pKa. So 17, 18, 19, 20, 21, 22, 23, 24. Oh, got lucky. All right. 0.1. pKa for oxalic acid is 6.63. So here we had one equivalence point around 24.1. I'm going to type that in here. Okay, so I'm adding more base now. Is anybody watching me, or are you guys all doing your own thing now?
I'm watching.
Well, sorry you're watching.
Sorry, I'm trying to do the one we just did.
Good,
Sorry.
that's fine.
Paying attention to this one. I'm
What?
me and Alyssa's advocate for this.
Say that again?
Alyssa had to go, so I'm paying attention for the both of us for this
Oh,
one.
you think so?
No, Alyssa had to go, so I'm watching.
Yeah, you think you're going to be able to explain to her what happens here?
I'm trying my absolute hardest. I'm very glad this is being recorded.
Well, yeah. Well, I'm not sure I know exactly what's going on here either. So we're trying to figure out.
We've been messing with this one for a few days.
What's
and
that?
I don't know what it is. We've been trying to figure this one out for a few days. And you know how good Alyssa is at this stuff, so.
I think that in this one, what we want to do is we want to actually make the graph. Chance, did you say you were actually making a graph before of your pH versus volume added?
Are these lab reports supposed to be submitted in PDF again, like our normal lab reports?
Yeah.
Okay, I'll fix that.
Sorry, my mic is muted. I didn't make any graphs.
Okay.
I looked at the graphs
All right.
that you drew.
Yeah. Okay, so it looks like we have gone to the end point. We've reached the end point there. Did this one provide us with any what's it called? Indicators? I didn't see any indicators. Yeah, I don't think so. Okay. So I think that for this one, what is best is to, so we found one of the pKa's. We found the first one here, or sorry, the equivalence points at 24.1 milliliter. And this was 24.1 milliliter of 10 or 0.01 molar base. Okay, and so now we have to we need to make sure we get the right exact value for that 24.1 milliliters. And we also need to find the other equivalence point, the other endpoint. And it looks like we're going to be approaching our endpoint when we reach about pH 11.2. So that's our base, here's our flask. So yeah, just probably pH 11. So, we added 100 mils, and let's see. We added 100 mils. Let's try it again here with our unknown acid. So we added 100 mils, and it took about 20 mils of that 0.01 molar to reach the equivalence point. So if we added 1 mil, no, if we added 100 mils, 0.1.
These are completely different. These aren't the titrated ones, right?
Aren't the what?
Are these the ones that you just titrated? I'm like, okay,
The ones I have on the board right now?
yes.
No, I just started over. I just got a new.
Okay.
I'm trying to decide how much acid mixture I want to put in, and if there's a better way to perform the titration with the
Okay.
0.1 molar. The 0.1 molar, I want a little bit higher than 0.1 molar is the problem. I want a little bit higher. I kind of want a point, or I can just add less of this stuff. So I had 100 mils, and it got there in about 24. So this time I'm only going to add 50 milliliters. That'll probably fix me up good. I can still use the 0.01 molar. I'll use my, get my, you ready? 52 mils. Going to add that to this one here. So theoretically, if my last titration was pretty close, then I should be reaching my endpoint at about not 24.1, but about 12.05 milliliters. Okay, because I only used half as much volume this time, 12.05. So what I'm going to do is I'm going to show you guys how to monitor how fast the pH is changing. Because when you look at a titration curve, if you look at the titration curve for anything, right? So in the case here where we have a titration of a acid, if we look at a titration curve, if you follow the derivative of the curve, which is the rate at which it's changing, at the equivalence point, it's changing the fastest. the pH is changing per amount of volume you add the fastest. Okay, so we can capture that rate of change by taking the derivative of our volume compared to the pH. So to accurately capture that, here's the volume that I have an estimate of. Half of that is what I'm after. So if I go to make a plot of pH versus milliliters of solution added, milliliters of base, okay. So here I have my titration. All right. So I'm going to add my volume. I'm going to get to 12, so if I go 6 to start off with. Did I do too much? Oh, that's okay. I'm at
You're looking at
titrate.
the pH right now, right?
What's that?
Are you watching the pH and the volume at the, is that what we're looking for right now?
That's right. So I just added 6 milliliters, and the resulting pH is 2.98. So now I can put that in here. 6 milliliters, and the resulting pH was 2.98. So if I insert a plot here, I want those to be switched because I want the milliliters to be on the x-axis. Oh, that's not right. I had it right. There we go. 6 milliliters, 2.98. That's right. So pH is over here. Milliliters is on the bottom. And I'll go adding my solution. So add 1 more milliliter. 3.07. All right. So I'm going to set myself up here so I can see both of these at once. There we go. 8, 3.18. It's getting pretty steep. Maybe I should go to 0.5. So 8.5, 3.24. Nine, 3.32. 3.34. 3.51. 3.65. 3.86. 4.24. So it's going pretty fast now. It's getting faster, so I'm going to decrease my volume change to 0.1. So from 11 point, whoops, what happened? All right, 4.39. .61. .05. It's still going really fast, so I'm going to change it down to 0.05. Okay, so let's try it. Let's add 0.05, 5.58. .12. Wait a second. We're at 11.9 now. Oh. Now we're 11.950. Oh no. I got off somehow. So 11.950 is 6.4. This one here was in between 11.9. .95. I think that this one here was 11.9 and this one's 11.85. All right, so then this one here should be 12. 6.57. All right, so now our pH curve is ending. Is anybody really still listening to me?
I'm listening, I promise.
Not that you have to. I'm just. All right, so
It's quite a lot, but it's okay.
what's that?
It's a lot to figure out, but it's okay.
You see how I made my own little pH curve, though? You see that?
Yes.
All right. So from this, I can identify the concentration of my first acid, right? My first acid. So my first acid ran out at this volume here, which is, I can rest right here, about 11.85 milliliters of this. And I can see that because that's the steepest part of the curve right there, right? Can you see that? How that's the steepest part of the curve?
Where the steepest part of the curve is where it runs out, not
Yeah.
like where it stops. Okay.
Yeah. And maybe even 11.9 is about right. But so now we're going to increase our rate of adding here. Add 1 milliliter. Wait a second, where are we at? 0.05. Let's add 0.95. Will that bring me to an even milliliter? Yeah. So now I'm at 13.7.48. So 13.7.48. Okay. And now I'm going to add 1 milliliter increments until I get close to some larger change. So now I'm at 7.78.
Report, do you want us to include this graph?
You could, if you want to. I mean, if you got the end point, that's all I really need to know. But this is a pretty graph, all right, so it'd be nice to include. All right, 15, 7.98. $16, 8.14. So now that's not tailing off, not flattening out really fast. 8.27 for 17. Let's see what that looks like. Yeah, it's kind of going up a little bit fast there. Because I got to pay attention to when it starts kind of going up. If it starts going up fast, then I have to start slowing down my addition, right?
If it goes up again, how do you know like which? Is there 2 endpoints?
Yes, there are. There are 2 endpoints. This first endpoint is used to determine the concentration of the weak acid. And then from here, wherever that point is, to the next endpoint, that's the volume you use to determine the concentration of the strong acid.
Okay.
I think I said that wrong, though. The first one is the one you use to determine the concentration of the strong acid. The second one is going to be the concentration of the weak acid. All right, so I add 18 mils, 8.38. Still not, I just think we're okay. I think if we keep adding 1 milliliter, I think hopefully we don't miss it. 8.49. Yeah, we look like we're okay. So just keep adding 1 milliliter, 8.60, until it looks like it starts to go up. So that was 20, 8.60. Wait, did I? Where's 20 at on here? Did it not show up? 8.71. Oh, I need to redraw my graph, drag it down a little bit further. Okay, does it look like it's kind of speeding up the change there? Or is that just me?
Yeah. Like barely.
Barely, yeah. 8.82 for 22. 8.93.
Hey, so I have a quick question.
Yeah.
So for the chemistry final, do I have to download Proctoro or anything?
No. Well, I think there might be a little download, but nothing that'll be time preventative. Nothing that you have to think forward to, as far as I know.
Or in Factorial for all my other classes, you just, once you click on the link, that will have you like add, it has to be on Google Chrome. It will add like the Chrome extension, and then it has to like, you have to allow the microphone and the camera and all that, but then you only have to do that like once per class.
And do you have it posted on the calendar? Because I can't see it.
The lab final?
Yes.
Or, sorry, not the lab final, but the course final, the class final, the lecture final? Is that what you're talking about, Chance?
Yeah, that's the one.
The course final. No, that's, I mean, in terms of a date, we're aiming to begin like the 15th. The ACS said it's not going to release the questions until the 15th. So it kind of depends on if it releases it early in the morning or late in the afternoon when I can get that test done. But I'm going to try to have it done before we go to bed on the 15th. And so then it'll be opening probably till the 19th.
Okay.
17th.
And it's the same as the other tests, like multiple choice and all that?
Yeah.
Awesome.
Okay, 24.
Is it timed?
I don't know. I'll have to look at their rules and see if they require it to be timed.
I vote not.
Okay, I'm going to go to 0.5 milliliters now because I feel like it's going up slightly. So 25.5. Yeah, it's going up. Well, is it? I'm not sure. Yes, it's definitely going up. So I'm going to go to 0.1. So
I don't know what number that is. Would
What's
the
that?
26.5 be the end point?
no, not quite. We got to watch it go up till it gets the steepest and then levels out, and then that will be till it help us know where the end point is.
Okay.
So where did we just do? 26.6. 9.52.
I can't wait to do this with my own.
It's exciting, I know. 9.52. 9.55. 9.57. 26.9, yeah, 9.60. Hmm. 9.63. I want to make sure I have written down here. So this titration is for 50 milliliters of unknown acid mix. Does that matter?
I like.
Oh yeah, it does. Yeah.
Yeah.
Because we need to have the concentration. That's what the unknown, or that's what we're after down here, is the concentration.
concentration of both.
Yeah. Okay, we're getting closer. 27.1 would be next. 9.65. 9.68. 9.71. It looks like it went up a little bit. 6.8, 9.771. Well,
Why are they so much closer together? Is that just because of the graph, or just because the pH can't go? It isn't going down as much.
say that again.
Why are like the dots getting so much closer together? Is that because of like the graph, or is it because the pH isn't going down as much?
It's because I'm bringing the smaller volumes. I'm adding smaller volumes, right? So I've just switched again to, instead of 0.1, I'm going to add 0.05. So I'm at 27.3 milliliters. This next one is going to be 27.35.
Okay.
5 milliliters. And then I'm going to want to highlight these down like that because 27.35, 27.4, 27.45. Yeah. Okay, so 27.3, and the next one's going to be 27.35, and it's 9.73. Okay, do it again, 9.74. That's not good. Did I already miss it? 9.76.
What's the, like, are we just going until the end point, or are you like trying to find a goal pH?
No, I don't have a goal pH. I'm just trying to find the end point, and this is going to flatten out. And then I'm going to try to look at the curvature and try to find out where the steepest part is. Yeah, I think I'm approaching this the right way. I'm trying to make sure that there's not something I'm missing. 9.79. That looks good. 9.80. That doesn't look good. 9.82. That's not bad. Did I click it? What's that?
I couldn't tell if it did or not.
It says down there 77.65, so minus 50 would be 27.65, but it has the same pH. 27.77, 9.83. 9.85. I wonder if I made a mistake there. All right. We're at 27.75, so this is 27.78. 9.86. 9.88. 9.9. 9.91.
Now that it's just moving pretty much at like the same rate, could you just
Could I do what? Add more?
now that it's at like the same rate, like isn't the next one going to be 9.92?
Maybe. Oh, pretty close. But yeah, if yeah, I'm not sure. Did I might have already got to the end point and we might be flattening out.
That's so many.
What?
That's so many numbers.
78.1, 28.1, yeah. Okay, so 9.96. 9.97. 9.99. 10.01. I'm going to go back to point 1.
What difference does?
Just speed it up.
Okay.
I'll go back to point 2.
It looks like that should be the end point for me.
It does, but I'd like to see it flatten out a little bit more. All right. So if I add this, am I going to get to 29.1? Oh, that was 29.1. So this is 29.3, 10.29. Okay, that's looking like it's flattening out a little bit.
Yeah, that last dot that just got put in there.
Yeah, we'll see.
So since all the dots are so close together, like how do you tell exactly where the endpoint was? Like one number.
Say that again?
Like since the dots, like they're so close together, it kind of looks just like a line. How would you know like what the endpoint was?
Yeah, I'll try to tell you. I'll try to show you here.
Okay.
It's, All right, for sure, right? Can you see it? It's definitely flattening out now.
Yeah.
10.57. Okay.
Yeah.
So we have two equivalence points. Now, like you said, how are we going to find the best
Endpoint.
endpoint, right? And this is the best way. Do you remember did you ever work with a derivative? Have you ever worked with derivatives in math yet?
That sounds familiar, but I was in trig and calc and all that stuff.
Okay. So a derivative is a fancy word for the slope of a line.
Okay.
And if we calculate the slope of the line, we calculate what we call the change in x over the change in y. All right? So if I look here at this point, I look at the change in x, I can use an equal sign here to get a little bit bigger. I can use an equal sign here and look at the change in x. So I'm going to go this minus this. That is my x value, my change in x. What is that? What is that typing right there? This. What's that RC minus 2?
I don't know what RC is. Or maybe that's like, ooh, I have no idea.
I'm going to put this in parentheses first. So this, I've never seen that before, minus that. And then divided by the run, whoops.
So just like rise over run.
That's right, this minus that.
Okay.
And then I can drag this down. And what this gives me is it gives me the slope of the line, change in the slope of the line over time.
So like the steepest one, like the highest one, would be.
Yeah.
Oh no.
Now this
Slope.
first one we can't really use. Oh, then yeah, these ones we don't want to use. These are, let's see, what are these? Why are these so high? So the goal here would be, I'm going to copy this graph and paste it. So I have two graphs. And then I'm going to take this graph and plot it with this here. Rise, oh, change, oh, I did that wrong. I did run over rise. Got to try again here.
I didn't even notice.
Change in rise, this is the y-axis. So it's this minus this.
Over to 7 over 8.
Yeah.
I mean,
This
7.
minus this. There we go. All right. So now I have a plot here that shows me
The end. All those like, that's the end points.
yeah, this is the end point right there. And then this
And then
one,
the other little one there, yeah.
yeah, the other one's not as pronounced. This one doesn't look very good here.
one just is really low.
So I would guess it's right around here. Now, the good thing about this one is it'll tell you the answer when you're done. So even though you got it wrong, you can learn for your next try what you did wrong. But let's take a look here. So if we said it's about now let's see. Is there something else in terms of calculations that I'm not thinking of? Let's look here. If we have the pKa of 0.66, then that would be pH. What would the pH be? pKa is 0.66, pH is 0.66, pKb would be 13 point something. So that's not helpful. pKa here 6.63, pH 6.63. So that, I think, could be useful for helping us identify the So let's see. Here we have the strong acid being consumed. And once all the strong acid is consumed, then the weak acid is being consumed.
Is it not as much of a steep rise because it's the weak acid?
Trying to think about this. This is our strong acid here. Protons go in, the protons in the strong, or the hydroxide ions go in, remove the protons from the strong acid. They're not being held at all. So that's the disappearance of the strong acid. Then this here is consuming the weak acid. So what do we got here? 11.9, 11.90.
You just pick like the middle dot.
Yeah, I think we want to pick right about here. So right when we know it's all gone. So like 11.9 right there. Probably the one we want to pick. 11.9. That's the volume for that's milliliters of the 0.01. Is that right? Are we doing that right? What was my acid here? Yeah, 0.01. 0.01. So 0.0119 milliliters of times 0.01. So that there's that many moles of our strong acid in the solution, and that was 0.05 0.05 milliliters of it. So that's 0.00238. 0.00238.
Why did you do 0.05?
Didn't I use 50 mils?
Oh, yes. Okay.
50 mils of my acid. I have 50 left over, yeah, and it's 80.9. So yeah. So that's the concentration of my strong acid. Now the weak acid, its volume. This is going to be a little bit tougher to choose. Wonder how could I get that better? Maybe I made a mistake in there somewhere. How could I get this better here?
Is there a way to like spread them out?
Well, yeah, I could zoom in my graph, but the problem is the derivative graph doesn't look any better, so you're not going to be able to see much if you zoom in there. The derivative graph looks horrible. But how could I have improved the derivative graph? Just use smaller volumes, but...
I feel like you would have to use smaller x values, like on the x-axis,
yeah.
so you can see more instead of going by, like, I don't know what it's going by right now, but...
Oh, so yeah, but you can try it so that you can look a little closer. So it's like 25 to 30. All right, so we can change the axis here between, instead of 0 to 35, we can change it from 25 to 30.
Oh, yeah.
Does that make sense?
Yes. Just play it to axes, just like we did with the spectrometer. Spectrophotometer.
Yeah.
I don't know that.
But this volume here still just doesn't have a really good point where it sticks out. Maybe right here, 27.9. What's that?
That's probably the one I would use. It's the highest one.
So 27.90 milliliters. So if we use the 27.9, this was our first equivalence point, right?
Yeah.
And this is our second equivalence point. So we have to take the difference between these two volumes, because for the second equivalence point, right, it was only from, so let's go back to here now. To here, it was only this volume there, right? So yeah. for the weak acid. So we need to 0.0279 minus that value there. So I'll take this minus this value here. Well, this isn't right. It's not 1 milliliter, it's 0.01. There we go.
Did you type it in?
I just typed it in wrong. Right? Because this is at 11.9 milliliters, not 1.19 milliliters. Okay, so this is the volume for the strong acid. Okay, so then first equivalence point, 0.11. We did the calculations for that already, right?
Yes.
And we put it in 0.00238.
That one is.
Let me double check that one.
So would that one not be 0.00019?
I think it's right. 0.0119 times 0.01 divided by 0.005. 0.0238, is that what we had?
I don't think so.
Oh no, we had 0.00238. Let's double check that again. Point what? 0.119. That's how many milliliters divided by what? Now times the concentration, 0.01 molar, right? And then divided by the 0.05, the 50 milliliters. Yeah, 0.00238. All right, and then the other one would be this volume, 0.016.
Then times 0.01.
Uh-huh.
And then divided by 0.
0.032. Wait, 0.0032.
Yeah.
Did I do that right? 0.016 times 0.01 divided by 0.05. 0.0032. That's not feeling right. Its concentration should be closer.
I think, did you divide by 0.005 on accident?
On the last one?
The first time, I think.
I
could be.
0.0119 times 0.01 divided by 0.05. Okay, yeah. 0.00238. So we were right, 0.00238. Now back to this. 0.016 times 0.01 times, or divided by 0.05. 0.0032.
Forgot a 0.
What's that? Ooh.
One more 0 on the other side. Yeah.
My goodness.
For significant figures, do the zeros after the decimal count as significant figures?
Yeah, so I should add one more. No, not before the value, but after a value they do. So I should add one more 0 in there just in case they try to get me for significant figures. Well, let's check, see if we got it. Oh, we didn't get it. 0.00238 and 0.0032. Trichloroacetic acid is trichloroacetic acid is a strong acid, and the pKa for alloxonic acid is a weak acid. So I'm just going to check it 2 more times and see how far I'm off by. Okay? Maybe maybe they're expecting it to be a little bit higher. If the endpoint for this one, where are we at? If the endpoint for this one was actually like 11.95, and this would be 15.95. So let me do the calculation in Excel here. Let me see. It's going to be this times 0.01.
And divided by, is it divided by 0.005 or 0.05?
0.05. 0.0239, is that what we said last time?
I believe so. I think it was 238, but I think you just rounded up.
Okay. So then .0319.
They're wanting it rounded.
What?
Wait, why is there two?
What's that?
Why is there? Okay, wait, I get it.
0.00319. 0.00239, 0.00319. Did I put 0.003? I put 0.20 last time. Let's check that. Ah! I'm just going to punch through and see what it was. So it was 0.237 and 0.324. 0.237. So let's see what they are using as their endpoint here. Instead of 0.239, 11.95, they used 11.85. So they used 11.85.
So they're using that one.
They're using that one right there.
Like which one it is.
Yep, dummy. I should have done it, but okay. So they use 11.85 there, and then if we use 11.85 here, we get 0.00321 there. Is that right? 0.00319. 319. So they got 319. So to make that 319, I need to change this endpoint to a lower value. Point 0.0279, 0.0275. Still off, right? Because they said point. Oh no, what is it? 0.324. They have 0.324. Sorry. Okay, so we got the first one right. What's that?
You just put that value into Excel to see what they used.
That's what I'm doing now. Yeah, I'm just doing that now to see what they got. So 0.270. 0.303. Let's see. What are they getting? Let me write this down this time. 0.324. Right. Is that right? Trichlor. Oh, no.
0.00324.
Yeah. 0.00324. All right. So okay, so they used 0.02805. So let's.
How do you know like which one to use? Like, because we used the one that looked accurate, but they didn't.
Well, let's look again. We might have not used the one that looked accurate. They used, what did they use again? 0.2805. 0.2805. So that's the one they used right there. How would we have known?
I hope I have the same numbers as this one.
You hope you have what?
The same numbers. Because each, like, sometimes, like, me and Alyssa will be helping each, like, trying to see, like, how to, but they're different types of acids. So I'm hoping my numbers are the same as this particular one.
Have you ever seen them repeat?
Yes.
Oh, good, good. Maybe you can get lucky that way.
Because Alyssa like 3 times and got it wrong. And so like finally, like the last time she knew what she did wrong, but she got it right.
Mhm. All right, well, let's see here. Well, the one thing that might be able to use is the pH, 9.94. Does that make sense?
Yeah.
So, actually, this could be really easy. If we use pH 9.54 and the other pH is 5.58, because they're going to give us the same acids, we know that, right?
Yeah.
Do you want to try it? Could be really fast, really easy.
Okay, like on my lab thing?
Yeah, so that you can use it.
Yes. Okay. Well, let me get back to it. Okay. So should I open an Excel sheet too?
If we're careful, we don't need it, but
Okay. All right. So I start with my acids mixture, and do you always pour it into a new flask when you do it?
as opposed to what?
Well, like, can you not just use like the already prepared?
Oh, but the volume is just so high, right? You don't want so much.
Okay. Pour in.
Here,
Yeah.
are you sharing your screen? Let me give. I guess you can't share your screen, can you? Let me give you your. Make you the presenter so you can share the screen.
So you put 50 in there.
50 mils is what I did. We really don't know for this one. It might be different, but.
And then okay. And then
Strong basis.
Okay, yeah. And then the
Yeah,
we do
0.01.
4.01. Okay.
Again, we don't know if this is going to work. This is just what I did.
Okay.
So,
Is that how much of the sodium hydroxide or in the flask right now?
say that again. Oh, that's the sodium
Is
hydroxide.
that
Yeah.
only the Okay. So
You don't have to.
how much should I start with like putting in?
Well, I brought up my Excel page here to make sure I know what concentrations were or what pHs we're after again. We're after 5.58 and 9.94. 5.58.
Okay.
So last time 5.58 came at about 11. So let's just add 1 until it gets close to maybe 7 and then stop. Or no, sorry, close to 5 and then stop.
Okay. Okay. Oh wait, no, 5 is the pH, correct? Yeah.
Yeah, pH 5. That's right. Now, if it starts changing really fast, you might want to stop at 4. I don't know. You want to make sure you don't go past 5.58.
Should I lower it now or
Maybe point. 0.1.
Oh.
Okay, go to 0.01. Woohoo!
That was really close.
All right. Try one. Okay, so what are we at now? We're at
5.57.
17.410, right?
Oh, yes.
Yeah, because you had 50. Okay. So try one more time. Wow.
5.2.
Okay. So 17.40. I'm not sure if this is going to work. Our brilliant idea, but
It
we'll
could.
see.
I have faith that it will work.
I don't. I think that it's very likely that there's something I don't know exactly right about this. So now we're going to 9.94. I wrote that down, 17.4.
Okay. So should I up it, like up the amount because we have to go all the way to 9?
Yeah. So maybe 1 milliliter until we get to about, we got to get to 9.94. So maybe 1 milliliter until we get to about 8.7. Whoa.
I know. That was 1 mil.
No, that's okay. That's okay. It's going to go through 9 really slow. So go ahead.
So should
Keep
I
going.
do 1 still?
Yeah, I think so.
Okay. Again?
Yeah, keep going until we get to about 8.8.
Whoa.
I think
Should
we're
I go
okay.
0.1 or 0.2?
No, I think we're okay. Just keep going until we get to about 8.8.
Should I lower it to 0.01?
I don't think you need to, but if you want to, you can.
Okay. I just went too fast.
Okay, keep going all the way to 8.8. Okay, there we
now
go.
I'm gonna lower it.
All right.
0.01 or 0.1?
0.1.
Oh my gosh. 0.8.
So
And then is it supposed to be
9.94.
Just okay.
Okay, slow down.
Okay. Should I keep it at 0.1?
Maybe. Yeah, just one more.
I'll just do one more.
Okay, maybe one more.
Okay, now.
Okay, so that's our beginning, which is what? 30.790?
Yeah.
Okay, and then let's go until we get to the 9.95.
Okay. That's at 30 point. Didn't even like move.
30.820.
Yeah.
Right?
Yeah. Okay. How did you get the 0.20? Like, how did you know it was 30.82?
See down below where it says 250 milliliters flask?
Oh, yeah.
Yeah. And we had 50 mils of the unknown acid, so the rest is our base that we're at.
30. Okay.
Okie dokie. So, calculation time.
You have to use the converting calculation on this type of problem.
What do you mean the converting calculation?
The one we did with the last one we did the unknown base problem.
Converting?
Converting it to the moles.
Yeah, we do. I was kind of just doing it in my head before, but on the last
No,
one.
I was just curious to know, so I can also help Alyssa.
So, should we do that? You want to do that on the screen or no?
I know how to do it. I don't.
Okay.
Whatever's fine.
All right. Then, what'd you get for the concentration of the strong acid?
I'm still working on it.
Okay.
So do you start with what was the first number? Like the first. I don't have the volumes written down.
17.4 milliliters.
So it's 0.0. Okay, I don't know how to. I know what the steps are, but I don't know how to like what form to put it in. Does that make sense? Like 0.0 this or not? Make sense?
Let's see. Let's. I'll take the presenter back, and we'll do that on here. Okay. Is that all right? Are you there?
Yeah, I'm right here. Sorry, my
Okay.
sister was talking to me.
All right. Moles of acid. Okay. Liters of solution.
Okay, so it's like the same one. Hi, Alyssa.
Alyssa, we're really close to solving this. We think. We're not sure.
It's only taken like an hour and a half.
All right. So, what goes here?
It wouldn't be liter, like the liters of what did we use? The NaOH.
Yeah. Go ahead and you can start filling that out there.
Okay. What was the first one? I didn't get it written down.
17.4. So 0.0174 liters.
This is so hard to write out.
Yeah, it's lame.
And then this goes to liters of NaOH.
Uh-huh.
.1 moles. And then, is this 1-to-1?
Yeah. Horrible.
Okay, I get the gist.
Trying to write with my finger. Ugh. Okay, so this is
Okay.
moles of NaOH down here, right?
Yes, and then this will be moles of acid. Or, yeah, right?
Yeah.
And then this is 0.1 liters, because did we use 0.1?
I thought we...
No.
What?
0.01.
No, I thought you used 0.05.
Oh, yeah. Okay, I was wrong. Yes.
Because the total volume's like 80 something now, right?
Yep. So it's 0.05 liters of the solution of the mixture. And then the moles is that, then that's just one on top, right?
Yeah. Or you don't even need anything there.
Okay. I will do that in my calculator.
Okay.
Really hope this works. .0348. I think. That's what I got.
Yeah. 0.00348. Is that what you got?
I just got .0348, but
Really?
I could be doing
0.0174.
times 0.01.
Oh, this is not 0.1, but this is 0.01.
Okay, that's what I'll fix. 0.00348.
Okay.
Okay.
All right. So the other one. How do we do the other one?
We have to do that again.
Yep. For, do you know what volume this time though?
Well, no, I didn't write down.
It's double check, but I think you should be at, well, we got to pH 9.94 at 30.79, so I think that's what we should use.
Okay,
so
so
we take-
30.79, but so like do this whole thing again, just with 30.79.
Well, no, because we have to subtract 17.4 from the 30.79, right?
Oh, yes. Okay. So, 37.9, is that what we said?
30.79.
30.79. Minus
17.4.
13.39.
Okay.
And then that's the volume, right?
Yes. Divided by 1,000 to get it into milliliters if you want to. Right?
.01339.
What?
0.01339.
What's that value?
The liters, or yeah. The volume.
0.01339, is that what you said?
Or 13.39.
Oh, right. Yeah, okay. All right, so
that
that's
goes-
that's right. Yeah.
Okay. I'm going to write it in my notebook so I don't have to use that thing. And then this one's 1 to 1 too, right?
Yeah.
And then, would it still be 0.05?
Yeah, because that's still the same volume. 0.01339. Right? Is that what you got?
Yes.
All right. So 0.01339 times 0.01 divided by 0.05.
0.002678.
Okay. So,
Moment of truth.
yeah, make your thing this desktop so we can watch it all together.
Okay. The first one we did, the first one is for the trichlorine one, right?
Yeah.
Okay.
Did you write it down somewhere?
Yes, I have it. I have both of them written down.
Or did you share your desktop?
I don't have it in the option to.
Oh, sorry, I gave it to Alyssa. There we go. This.
So 0.00348. That's basically the same figures, right?
Hold on just one second.
Yes.
Okay. All right. So you got on there 0.00348.
Yes, and then this one is 0.00267. Oh wait, yeah, 2678.
What? 268 for 3 significant digits.
Okay, so 268.
Criminy. All right. No! Sorry. We worked so hard.
What did we do?
All right. Sorry. What did we do wrong? Nuts. It's 0.0023. Nine 0.00319.
Wait, for which one?
I'm trying to look at the last one and see what we did to get the.
The last one was 13.39 and then turned into 0.01339.
So let's see. You still haven't. We still have a chance, right?
Yeah, I still have 2 more tries on this one. Yeah.
Yeah. Let's double check our volumes. The first volume was 17. The second volume was 13.
Yeah.
First volume was 17. The second volume was 13. So the first volume should be higher in concentration. The first volume was 17.4. The second volume was reached at 30.79. Maybe if we try so what was the calculation for the second one? 0.00268.
Yeah, 0.002678, which rounded up to 268.
So let's try. I don't know. You want to give up? Haven't been here 3 hours yet. What's that?
I'm fine, whatever.
Let's try.
I'm not doing this, and I have to go do other chemistry for not lab, but the other one.
Let's try doing it again. Now, this time, we'll try to plot out the curve as we get close. We know the values that we're going to be close to, right?
Yeah.
Which are 17.4 mils and 30.79 mils.
Yes. So do I like clear this whole workbench? And
Yeah.
Start over?
Yeah. Let's clear
Is there a way to
this.
just like clear it?
Yeah.
Remove it all.
So are you sharing your screen already, or? Yeah, okay.
Yeah, I think that's fine. Okay. Acids mixture, and then 0.01, yeah?
Yeah.
What? 50? Yeah. All right.
All right, so what was our volumes again? Let me write them down here. 17.4.
And 30.79.
So
Okay.
you might as well go up to 16, and then we'll just add. So you can add 16 to start off with. Are we gutsy enough to do
Pour
that?
it in.
What's that?
Just pour it in.
Are we gutsy enough?
You know, it's okay. I can clear it and do it again if I need
That's
to.
right. That's right. 16 mils. Go for it.
The pH barely changed. Okay.
17.4, right? Huh?
What is the pH? What is it supposed to be the first time?
Well, we don't know if that's necessarily right because I mean, I think it's right, but 5.58 is where we were using. We'll see how close we were. So 5.58. I'll type that down.
Is 5.58 more?
Yeah, and then the other pH was 9.94. I think that should be right, but we were a little bit off on that first one, but man, I wouldn't think that would have made that big of a difference. Okay, so here we go. What are we at? 16. Let's go 0.1,
Yeah.
right?
Yep. Wait, so we're trying to get to 5.58? Yeah.
Hold on. So what was 16? I didn't write down that pH. What was it?
I wrote down the wrong number. Melissa, are you watching?
It's all right. 16.1, 3.7. Okay, and now we're going to go to 16.2, right?
Yep.
Okay, go for it.
3.74.
Okay, got it.
3.78.
Okay, got it.
3.82.
Mm-hmm. Got it.
3.86.
Okay.
3.91.
Okay.
3.97.
Okay.
4.04.
Okay.
4.11,
Okay.
4.21.
Okay.
That's at 17, so I need to go to 17.4, right?
Yeah. I mean, that's what we had last time. I don't know what we would have done different, but.
4.33,
Uh-huh.
4.49.
Okay, maybe we gotta go, yeah, because what were we looking for? 5.58?
Yeah.
Maybe we gotta go smaller increments, like 0.05 instead of 0.1. Okay?
Okay. So at 17.3, it's 4.76.
Uh-huh.
4.99 at 17.35.
Okay, got it.
5.44.
Okay.
Jump. Should I lower it because it just jumped a lot?
Wow, man, I think we gotta be okay with this. Let's see.
0.05.
Let's see. You could go 0.025, sure.
Oh, we jumped over it.
17.4. What did we just add?
0.25.
25.
0.25. So it's now at 17.475.
5.79. What were we trying to get? 5.58.
Yeah.
Wow. I can't imagine that would be it. All right. So what's the next one? Go ahead. Do another one.
6.08.
Okay. And then one, maybe a couple more. 6.28.
6.28.
Okay.
6.42.
Okay.
And then 6.53. And then 6.61.
All right. That should be enough. So 17.35 and 17.4. So it's in between there. Or maybe it's right at 17.4. What did we do last time?
17.4.
Oh, brother.
This is so fun.
17.35 to 17.4. Maybe it's 17.375. Would that change anything if we did 17.375?
Well, the pH jumped quite a bit when we moved 0.025.
$17.375. That would make it, I would still have it at 0.00348, the concentration.
Would it make a difference if we changed to a different, like 0.001 of sodium hydroxide?
Yeah. Well, it would, yeah, it would be equivalent to adding smaller volumes, right? But the problem is the difference between our small volumes that we've added. Like, for example, if we do the calculation we did to determine the concentration, and we use 17.4 or 17.35 or 17.425, So if we use 17.4, our value is 0.00348. If we use 17.5, our value is 0.0035. If we do 17.45, it's 0.00349. So let's see. What did we guess for the last time?
0.00348 and 0.00268.
Man. Well, do you want to try
That's like
0.003? What's that?
Like the same answers if you do it with 17.35 or 17.4.
Yeah. What about 17.45? That would give us 0.00349 and 0.00267.
Try it. 267.
Yeah,
And try it.
sure.
Oh,
Yay, praise the day. We got it.
2 hours later. Can't get the date in at the same time as I get the.
Hey, there you go.
Oh, thank you so much.
Yeah.
I'm so sorry that you had to stay for the typical lab time when we don't even have lab.
No, that's fine. That's what we got to do. All right. So what was the solution there? What did we use again? 17.45.
4, 5, I think.
Yeah, so to me, that's a little bit past the midpoint. That's way past the midpoint. And the pH isn't 5.5. The pH that time is 6.0, essentially. Well, Camille, Alyssa, should we do yours to get it out of the way?
Alyssa doesn't have her microphone on.
Oh, why not?
I have no idea. I mean, I don't even know what time it is in Georgia, but.
Oh my goodness, yeah, 2, 3, 4, 5, 6, 7, almost 9 o'clock.
Oh, she's
Hi.
Hi.
I just didn't want to interrupt, so I didn't want to have my microphone on.
That's fine. So we'll make you the presenter, Alyssa, and you can go get the mixed acid one, and we'll try to do it real quick, okay?
Okay.
Alyssa, I'll stay on here for moral support.
Oh, thank you. I appreciate that.
I'll be right back.